The gentleman on the left is a salesman for Donald Engineering, and he specializes in selling high-quality pneumatic systems and components. His primary duties include teaming up with various manufacturers around the industry to ensure that their pneumatic needs are met. One of the biggest problems this salesman faces on a regular basis is that he is faced with competition that offers much lower quality junk for much lower prices. Needless to say, this often puts his customers in a bind because they are unsure if his advertised higher quality components are worth the initial cost of investment, or if they are better off taking the cost savings offered by his competition. The salesman decides that if he can find a way to prove to his customers that his higher quality components are worth the initial cost of investment, he can save both his company money and the customer's money. The general idea involves creating a device capable of being transported into the field and hooked up to the customer's machine for an extended period of time. This device will then calculate the air that flows through it over this period of time and accept an input of electrical cost used to create this compressed air, thus computing the cost per unit of compressed air. This will allow Donald to illustrate that the higher quality components it offers will save the customer money in the long run. We are Senior Design Team 2, tasked by Donald Engineering with creating this device. Our team consists of Grant Johnson, Lucas Frybarger, Nathan Gradberg, Chris Peeters, and Cole Schneider. Our team advisor is Dr. Jaclyn Johnson.
This is a pneumatic flow totalizer. The totalizer is made up of 9 main components. We have the HMI, which shows our data and performs the calculations, and we have our electrical system, which powers the entire system. If we remove these, we can get a better look at the guts of the system. There's 2 valves in the system, which are used for controlling the flow path. The poppet valve controls which path the air will take based on the amount of air going through the system. So for low flow, we have 1 to 10 SCFM, and then for high flow, we have 10 to 160 SCFM. There's 3 sensors in the system. The 2 shown here in the front calculate air density, which is needed to calculate airflow from pressure drop. Then we have our differential pressure transducer, which measures the drop across the orifice plate. So air flows through the system in the following way. It enters the system at the connection shown there, flows down through the manifold and into the poppet valve. At the poppet valve, the air can go one of 2 directions, but that's dictated by the poppet valve. So it flows down to the orifice plate, goes across the orifice plate, and provides a pressure drop for the differential pressure transducer to read. Then flows up the hose, into the shuttle valve, and out of the system.
As the project comes to an end, Team 2 identified the replication cost of the pneumatic flow totalizer to be roughly $1,900. A typical manufacturing company should easily be able to decrease this value to around $1,500 due to connections with suppliers in the market. Moving forward, the team will be providing 2 unique enclosure designs to Donald Engineering. Aside from ordering one of the provided enclosures, Team 2 suggests that Donald Engineering utilizes the detailed test plan provided as an extra deliverable to finish testing the pneumatic flow totalizer.